Hello, my name is Brian Toe, and I am representing the state of Oregon. My project, Reactions of Salvinia to Copper Contamination, Death, or Absorption, studied the effectiveness of salvinia, a floating fern, for the removal and absorption of copper in copper-contaminated water. The inspiration for my project actually came up when my teacher turned on our emergency acid showers. Instead of water that is technically supposed to protect us, there came streaming, thick, red dust. Not only was this very disgusting, but it emphasized the greater problem of heavy metals and other contaminants entering our water systems. My goal, therefore, was to research a method to prevent this contamination from happening, and I first found out about duckweed, known to be a bioremediator for copper and other metals. However, when my teacher showed me his collection, I found that living alongside it was another bigger plant, salvinia. With a higher biomass and with the same harsh living conditions, I predicted that my salvinia could have a higher capacity for absorbing copper from water environments. So my procedure consisted of a constant mass of salvinia plants within different copper concentrated waters. I used 5.2, 6.5, and 10.4 ppm, which aren't actually random numbers, but are in fact multiples of EPA's 1.3 parts per million, which is the maximum concentration for safe drinking water. In addition, I had two controlled environments in which one had no copper and only salvinia plants, and the second controlled was the other way around, to make sure that no other variables were changing my copper concentration data. After going through the ICP-MS process, which is this instrument right here split into two parts, ionizing plasma by heating an electromagnetic coil, it went up to 10,000 degrees Kelvin, and then a detector receiving an ion signal proportional to the concentration. Basically, my plant samples were placed into this instrument, and I was able to receive calculated copper concentrations inside my plant and my water. To sum up my data, I found an increase of over 1,400% copper concentrations inside my plants. Here we see a plant of the control group with no added copper at around 4 parts per million, jumping up to over 60 parts per million in the 6.5 and the 10.4 group. In addition, the salvinia plants were able to decrease the copper inside the water by 75%, from 10.4 to 2.6, and from the 6.5 group to 1.4, which is just 0.1 away from the EPA's approved 1.3. The findings of my project demonstrated the effectiveness of salvinia plants for the absorption of copper in copper-contaminated water. Duckweed had been extensively studied as a bioremediator, but salvinia lives in the same conditions and has a higher biomass and thus a higher absorption capacity for copper, possibly even other metals. Therefore, in the future, I would like to test a wider range of copper concentrations and different metals even. I could also use time as a variable to optimize the absorption rate of my plants. With the possibility of salvinia plants acting as a bioremediator, these plants could be implemented into a design that removes copper contaminants from farm or factory use before the contaminated water even enters an aquatic environment. Even further, a chemical process could be researched to possibly recycle and reuse the absorbed metal. Thank you.